Hi, this is Dr. Bardot, and I'm going to give a little tutorial on uh, linear targeting in robocode. So this is the follow the leader robot that we made the other day, and I've made one little change to it. Um, I've taken out the the firing because I'm going to put in a targeting idea, and I'm going to show you a way to kind of evolve your robots rather than writing them all over again. So I like this follow the leader guy. Once he finds them, he's on him. So I'm going to use that as my base. So I'm going to click over here in my robots package. I'm going to create a new robot, and I'm going to call this one linear follow. And I'm going to say that he inherits from follow the leader. Click Finish. And so now linear follow, you can see here, extends follow the leader. That means he gets automatically the run method, and he gets automatically the on-scanned robot method. And now I'm sort of happy with the run method. It's the on-scanned robot. That's where I want to do my linear targeting. So I'm going to start to override that. It's going to be on-scanned robot, and it's going to be a scanned robot event called event, and put that in. Did I do that right? Go back here, check. I'll just copy this, and it will be definitely correct. So, all right. But now you're thinking if you think for a minute, you'll think, uh-oh, that's not so good, because what I'm about to do is overwrite what is in the follow the leader, and this is some complicated stuff that I worked hard to have it do. So I would like it to still do those things, even though I want to add in a little bit more. And so the way we reference that is through the keyword super. So super, just like this, references this class, super references that class. So I can say, let's do the on-scanned robot event method in super and pass it the event. And so that this line means that all the good stuff in follow the leader on scanned robot happens here too. Okay? All right. I think we still want to do if event name dot get name dot equal no, it's get name equals this dot leader, because linear follow is a kind of follow the leader. It's got a leader instance variable. So now we'll put in all the stuff we need here. too much code, let me give you an idea about how linear targeting works. So I've got this little picture here. So imagine that this is your tank. So this is you. And this is the bad guy. And if you see him, if you shoot at him the moment you see him, he's moving along in this direction. It's probable that you won't hit him. So what you do is you calculate where he'll be after another turn, and you calculate where your bullet would be after 2 turns. And see, you still didn't hit him. So you make him move another step, and you make your bullet move another step, realizing that your bullet's going to be going in a slightly different direction each time. And you keep playing this game until get rid of that. You keep playing this game until the bullet ends up going sort of past him. At that moment, you know that that's a pretty good direction to shoot because the bullet will definitely travel far enough. So what we're going to do is we're going to have a while loop, and we're going to see how far the bullet would go and how far away you believe the enemy is if you assume he just keeps moving in the direction he's going. All right, so let's code this up. We want to do the linear tracking. We're going to need to know where we are so that we can find out how far away we are. We're going to need what we're going to call the absolute bearing. So this isn't just the bearing of of my enemy, and I'm going to use radians here. I'm also going to add onto this my heading. So that's sort of the bearing as measured from 0. And then this is going to help me get how far the enemy is. So it's where I'm at plus how far away it is times math.sine, and I'll use absolute bearing here. Then we'll need to know which way the enemy's going. That's going to help us track where it is in the future, and we'll need to know how far we'll need to keep track of how much time we have elapsed. We'll set that equal to 0. And we'll need the width. Oh, we don't need this. Okay. We'll have where we predicted my enemy is, and we'll just set that out to be enemy x and enemy y. And we'll say while plus delta time. This means we're going to add 1 to delta time. It's just a shorthand way of saying to add 1 to delta time. So that's how much time we have times how times this formula, which tells me how far the bullet that I'm about to shoot will go. So I have a slight problem there because I haven't defined what that is yet. And I'm going to use a class called point2d to get my distance function. This is just a fancy way of doing the distance function, sort of like the math class. This is another class that is in Java. I think I'm going to make sure that bullet power has been initialized and that it's 3. I think I've got some problems in my parentheses. I'm going to have to import point2d. Not too surprising. Again, it's saying it doesn't like my... Oh, and now that's all better. Okay. What am I supposed to do over and over is re-predict where my enemy is. So I'm going to say my predicted x is going to be what I was before plus, so this plus equals is a shorthand way of having Java add on to a variable. And we will add on what we would get by moving in the heading at the speed that we are going. Now, one thing that can happen here is that my predicted x and y might be off the screen, which is sort of bad. So I'll leave it to you to think about how to exit the loop if predicted x or predicted y is too small or too big. And I'll say that you need to use, I'll give you this command, break. Break is a way of exiting a loop, forcing an exit from a loop. So you might use an if statement there. Okay, so now delta time is big enough, and we now know where we want to shoot at. We want to shoot at predicted x, predicted y. So let's figure out what that angle is. We'll call it theta. That's a very typical name for angles, and we're going to use one of these Udel's methods. And we're going to use this arctangent method. Because of the way that robocode works, instead of having to shift how arctangent gives its answers, we're going to sort of do a different kind of shift. We're just going to put in the x's first instead of putting in the y's first. This does the same change as things we've done previously to this. Okay, let me return that down here so you might be able to see it a little better. And so we're going to this set turn gun right radians. Again, use this Udel's theta, which is the direction we want to shoot, minus find the way that we're shooting now. And once I've done that, I'm ready to shoot my bullet. Okay, let's take a look at how this runs. So I'm going to use my linear follow, and I'm going to try him against walls. doesn't really seem to be working so great. Okay, so I think I figured out the problem. And here's what it was. So take a look at how it's working now. It gets the lock, it finds him, and you can see he's shooting some long range bullets there. Some of those hit, a lot of those don't hit because he changes direction. Some of them don't hit because they're aimed off the board, and that aiming off the board isn't a good thing. Um, and it's still sort of a guess, because maybe he won't be where we think he's going to be, because we're sort of there's just not a good shot. So, but you can see he is able to beat walls pretty often. And the problem is that in robocode, the radar and the gun turn together unless you tell them to not turn together. So as I was turning the gun, I was turning the radar, and when I was returning the radar, I was turning the gun, and I wasn't synchronizing those two things. So the way that I fixed that is I did in my linear follow, I did set up a public void run method, and I just told it to adjust the radar for the gun true. So you can read the documentation for yourself. All right. I hope that helps. I hope you have a good day. I hope you can make a robot that uses linear tracking and targeting.